Let's say we have a list of numbers, and we wanted to find the odd numbers in that list. One way to do this is to use list comprehensions, as we learned earlier in the class. Here, the list of odds is only going to be the values of n, where n is an element in numbers, and that n is odd, which is what this statement results in. We can also use the same construction to turn this list of numbers into a list of squares of each number. These types of operations are so common, in computer science we give them a name. This is usually referred to as a filter, and this a map. When we're filtering, we take in a list of numbers and some criteria, and only return the numbers that satisfy that criteria. In a mapping, we take a list of elements and some operation, and we perform that operation on each element. Python actually gives us built-in functions to do this. So another way to write odds is to use the built-in function filter, where we give in two arguments. The first is a function that we create anonymously using the lambda notation that returns true or false. True if n is odd, and false if n is even. The second parameter is the numbers. And so filter is going to return all the numbers that when inputted into our first parameter, this function, return true. Here's how we generate the squares using the map operation. We pass in two parameters, just like we did with filter, where the first one is a function, the second one is a list. And map returns a new list that is the result of applying each element in numbers to the first parameter that we gave, the function. This problem asks us to create what is known as a higher order function. That is, we're going to create a function that generates a function that saves us time from having to repeat this first part of the filter and the map every time we want to reuse the same operation. So ideally, instead of writing filter of lambda n mod 2 equals 1, we're just going to create an odd filter. Here our filter maker creates a new function that takes in one parameter, numbers, and applies filter in the same way as we have up here, because we've already passed in to the filter maker the function that we want to use filter on. There are two ways you can solve this. The first would be using the lambda notation, and the second is using inline function defines. Here we're creating a function using lambda. That's what lambda does. It's a function that creates a function that is a list comprehension, where for every element in our list, which is the one parameter into our lambda function L, we're going to leave it in the new function created by this list comprehension if that element satisfies our function f. In this alternative solution, I'm using a nested function declaration, where we're creating a function that takes in a list and returns the result of filter of the original function that we used to create our special filter f and the list that we just passed into this function. So that's how we do this for filter. Let's do the same thing for map. And just like before, we can solve this in two ways. First, we'll go over how to do it with lambda, and then we'll briefly go over how to do it with a function declaration. Here I'm creating a function that is just a list comprehension that returns the result of applying each element in L to function f. In this alternative solution, we're defining a function, your map, that simply returns the result of using Python's built-in map with parameters f and the list that is passed in with applying your map. And the last line is returning the mapping function we created.